Okay, here we are. You've either listened to the first chapter about who we are and the problem that we're solving, or you skipped right ahead to this chapter because you want to know more about the actual product itself. So let's dig in just a few slides here on what we have. The wave tunnel system really has three fundamental components. There is the antenna, which is a 60 gigahertz antenna, beamforming, multi-phased array. It's extremely narrow beam, and with this narrow beam, we get a high spectral reuse as well as quite a bit of system gain in the antenna itself. With this system gain, we are able to go through most interior walls, sheetrock, wood, glass. All of these can be penetrated by a wave tunnel system, and in some cases, you can go through 2 or 3 of these walls in a single link. This simplifies the deployment by taking that line of sight requirement for 60 gigahertz and removing it. In addition, with the beamforming, we go plus or minus 45 degrees, and I'll show you a little bit later how you can steer around corners with this beam steering. So between the ability to steer around corners and go through internal walls, deploying a wave tunnel system is as easy as it gets. This antenna is hooked up to the node, the box, and we'll show you a picture of the box in just a little bit. Maybe if you can see this. This is a wave tunnel box. I'm not sure if this is coming through, but it's basically a bridge with 4 PoE ports on it. You configure and manage this device with your smartphone, and it goes up to 100 meters in distance. You can add, drop, or relay traffic onto the ports, and each of those PoE ports supplies up to 60 watts for an external device. And just as important as the antenna and the node in the physical box is the software. Our VineSuite software consists of VineOS, VineManager, Airvine Mobile, and VineIQ. The box itself, as you can see, it's a little bit about the size of an Xbox. It would be hanging on the ceiling of your deployment, and you can see the PoE ports and the DIN connector for power on our Wave Tunnel 2041 SM. As mentioned, 1 to 2 gigabits per second today, with more tomorrow. Each box has a radio on each end, and that's how it can go point to point to point to point. The high gain beamforming antennas, 4 gigabit PoE ports, a layer 2 switch, and then the Airvine mobile app that you run on Android or Apple and gets you down to about 100 meter hops with 2 milliseconds latency per hop. A little bit about the software. At the very bottom of the VineSuite software is VineOS. This is the operating system that the units use to make basic connectivity, and it's also what supports our Ring protocol, which we'll mention in a little while. VineManager is a web interface. Any browser, any computer, anywhere, you use this to configure, monitor, and manage the wave tunnel network. And Airvine Mobile is our app. This app is primarily designed for configuring and accessing some remote, a little bit of quick troubleshooting, but really the heavy lifting in terms of monitoring and troubleshooting your network is with the VineManager. And to be introduced next year is VineIQ. This will be an intelligent agent that will monitor the entire network in real time, adjusting and optimizing for your overall network performance. We see VineIQ as an AI-enabled application, and it's AI, the particular machine learning algorithms are perfect for this application, as the more data, the more networks, the more information and links that the system can monitor, the better it will be at optimizing a network and predicting failures before they happen. Setting up a network. Here's an app. Here we are on an iPhone app. You can see on the very first screen, you create a network. The next step, label that device that you're talking to. Third step, confirm the settings. Fourth step, you're done. You can use this app to configure a wave tunnel node 5 minutes or less, and if you know what you're doing, it'll be much less. Here's a few screenshots from the web GUI, the VineManager. These screens are available on the VineManager or Airvine Mobile. And you can see basic screens. You can see performance. You can see the ring. How is the ring doing? Those links are blue, which means everything's operating properly. You can see a dashboard for throughput, for capacity, CPU. How is the unit holding up? Temperature is up. All of this information is available through the VineManager or the Airvine mobile app.
You mentioned some of the features of the antenna, such as the beam quality, the signal strength, etc. What does all that do for the user?
60 gigahertz has been around quite some time, and people have always looked at it because you can do so much spectrum, you can do so many gigabits, but it's always had these issues in terms of how far it can go. It's always needed to be line of sight. You can't have anything in between it. And these restrictions really limit how useful the 60 gigahertz band is. The breakthrough for us that enables people to use our system like this in the 60 gigahertz band is in the antenna. Because with this antenna, that's what enables us to penetrate walls. With this antenna, that's what enables us to steer around the corners. So it's not technology for technology's sake. That particular technology is enabling you to go through walls and bend around corners. Two abilities that make deployment much, much easier.
If I need additional coverage or I need additional performance, how can I boost the network above and beyond the numbers that you're talking about?
The network, the performance today is between 1 to 2 gigabits per second. We do have a roadmap that has a release coming out next year that will double that capacity, and we do have a longer term roadmap where we expect to get 10 gigabits full duplex. So if you need more capacity, what we would recommend is that you deploy different spurs. So we've had deployments where you have more than one spur connected into your backbone. One set of wave tunnel nodes will be connected point to point to point, and they'll go off and get all the access points on this side of the building. You can have another spur independent of the first spur that goes off and supports additional access points or devices in another section of the building. But that's how you would increase capacity. If you needed more than what we can do, you would have multiple backbones.